Hey guys, welcome back to the Academic Powerhouse with your mathematical meathead himself, the realest guy in the room. Bada bing, bada boom. How you doing? How you doing? Let us continue talking about statistics. We have journeyed far, yet there is so much farther we can go. Isn't that the beauty? That is beautiful. That is amazing. But baby steps, guys, baby steps. I know you want to get through this. I know you want to start telling your statistical stories of truth. You want to start collecting data and analyzing data and interpreting it and then finally presenting it. Rest assured, we will get there. We will get there. We will get there. We spent a couple videos ago talking about center and how we can calculate center through mean, median, and mode. More recent videos have talked about spread and how to calculate spread, or in other words, measures of variability. We talked about calculating range. We talked about calculating interquartile range. And when we perform our calculations, we can get a shape to our data. We can get a sense of that distribution. And when we have center, spread, and shape, we can then thus tell the story that the data is trying to tell. But I want to spend this video talking about one measure of variability in particular, one that can be a little intimidating, can be a bit calculation heavy, but rest assured I will guide you to the promised land of enlightenment on this topic. And that is the topic of mean absolute deviation. Mean absolute deviation. Let's break that word down a little bit to help us better understand to help us better understand. So, so with that said, let me switch to my pen here real quick. Actually, yeah. So I like to talk about things in a very broad, very high level in these subjects in particular. Visualize the concepts first before we dive really deep in. So that's why I want to look at the words here. I want to look at a basic visualization here. Now, if you're not familiar with these visualizations, rest assured we will spend many, many minutes, many videos talking about them. But this here is a dot plot, and this, what you can interpret from such a plot is that you, for each dot, that is indicating a data point, So, for example, 1, there's 1, 1, there's 1, 2, 1, 3. And there are multiple 4s and so forth. And if you remember from how you calculate measures of center, mean and median, you would come up to determine that, your median is 4, your center is 4, your mode is 4. So, with that in mind, let's break this word down. I just said mean, right? Mean. Remember what mean is? Mean is the sum of all the data points divided by the total count of data points. So that alone should tell you that we'll be doing something along those lines here. Let me skip absolute real quick and talk about deviation first. Deviation, that's probably the most foreign word to you. You may not know what it means. That's okay. Deviation is essentially a word that says anything that deviates from the norm, or in our case, the norm is the center. So anything that deviates, any data points that are not the center, as we're saying, is 4. So anything that's not 4. So for example, 5, 6, 7, 3, 2, and 1. These are not 4. These are not the center, and therefore, these are deviations. Now also remember, when we talked about other measures of variability, such as inner, well, actually, let me even back up before then. Remember how when we were talking, remember what median is? Median is splitting up our data. And when we looked at interquartile range, we looked at first splitting our data in half, and then splitting it again into separate quarters that we can then, you know, look at separately. So when we talk about mean absolute deviation, we're talking about like you can take the average of all of your data and get a number, right? So all this 1 through 7, including all these fours, but you can also take an average of sections of your data, such as what we did with the interquartile range. We looked at different sections of our data set and we found the middle of those. We found a subsequent middle, right? Q3, Q1, subtract those, get a interquartile range that lined up with to be 2/4 of our data or 50%, right? Just this little area here, and then all this was empty or not really looked at and accounted for. Mm, things are clicking now, right, guys? Yes, yes, yes. We can do so many things with math. We can look at things as a whole in pieces, and that's essentially what we're doing here with mean absolute deviation. We're looking at in pieces the deviation. Now, absolute, I said I was going to come back to that word, absolute. You should know this by now, but if you don't, that's okay. That's okay. Absolute means, what it means is, actually, it's probably best to see it through written means. So it's saying that, let's say you have 1 minus 2. And absolute means, straight bars around your numbers, right? If you have something like 1 minus 2, from basic, it's -1. Basic number sense, basic, working the number line, all that stuff, -1. But absolute means no matter what happens in here, 1 minus something, 1 minus a million, 1 minus 2, 3, whatever, if you would normally get a negative number, absolute just means, yeah, okay, whatever, just change it to positive. So that makes sense. That makes sense in what we're trying to do with statistics, because if we're trying to look at things that differ from the center, we can look at things that are bigger than the center. So big, so for example, 7 minus 4 would normally be a positive number, big minus small. But also we can look at things that would deviate from the center in this direction, which you would typically associate with a negative values. If we're saying this is our starting point, and we're trying to find deviations, right? 1 minus 4 would be -3. But if we're saying absolute, it's not -3 anymore. It's just plain old 3. Anyways, so that's kind of the high-level breakdown of the words themselves. Okay. So let me run you through this quick little example. I have a more thorough example here, but I want to make sure like we're at a high-level concept right away. We're getting this idea. So mean absolute deviation. So I want to look at the average amount that these data points are from the center, is essentially what it's saying. The average amount of distance away from center that these data points are. And I'll look at these other ones here in a second. These ones here on that side. But let's focus on this side first. So I can do I already know how to do mean, right? 5 plus 6 plus 7 divided by, there's 3 of them total. So you add these up, you get 18 divided by 3, it's 6. 6. Now again, this is just what? The average, or even the mean. This is not the average deviation. This is simply just the average of this section. Now, deviation. Think about that. Deviation. Well, absolute. Right? 6 minus 4. All right, this is the deviation from center. This is how you want to structure it when you're going through all these different problems, as you'll see here in a few moments. Structure it like this. I'll use the letter V for value, minus your center, you get some number. In this case here, take our 6 minus 4, 2 equals 2. That 2 right there, the 2 is what we're saying to be the mean or the average deviation, or I guess technically absolute deviation, or the MAD for this side of the data. You'll see that it's very similar. You'll see it's very similar if I did the same for just this section of the data. In fact, let me do so. So I gotta erase this real quick. So remember that, it was 2. Remember, it was 2. In fact, I'll even write it here on the side. This was 2. Now for this here, same thing, average, 1 plus 2 plus 3 divided by 3, 5, 6 divided by 3 equals 2. Again, that itself is not the deviation, that's just the average of those values. And now I take my value, which I said to be 2, minus the center, which I know is 4, and it's not negative 2, not negative 2, no, no. Because of these absolute value bars, it's simply 2. And that is the MAD, just for this blue area of data. Well, as you'll see in the next example that we go through, the mean absolute deviation in totality is 2. In totality, when you look at, regardless of which section you look at, the totality of all of it is going to be 2, as you'll see in the next example here. But hopefully this high level, broad brushstrokes gives you a sense of what we're doing with mean absolute deviation, what deviation means, what the word mean means in absolute. Let's work through an example. I'm going to use the data we used when we talked about interquartile range and range. Right, this data. So it's a little familiar to you. I set it up in a nice, organized little table. It looks nice and pretty. Right, here I had my 7, 8, 10, 11, 14, 29, 30, 35. So I'm breaking it down into little baby steps here so that we can see clearly what's going on. So I have my data here. I also took the liberty, because I know I'm going to need to know average, I'm going to need to know the mean. As you see, I'm going across the totality. This one is not, I'm not just breaking it into sections, I'm going across the totality of it. So I'm trying to find the mean of all the numbers here. So I went ahead and found the mean of the whole data set, because I'm going to use it here in this next one here. Okay, all this added together is 144 divided by 9, because there are 9 numbers, you get 18. I'm going to use that 18 here in a second, as I'll explain. So, okay, again, deviation, the center, as we're determining, is 18. So we're saying 7 deviates from that. 8 deviates, 10, 11, 12, and all these numbers, they deviate from the center. So the way you should kind of break these out, you should set your problem up in a table like this, and you should break it out as I'm about to do here. Now, here's kind of my general template, as I said above, right? V minus center. Instead of V in the word center here, what I'm doing is using X's, right? X to indicate my data point, and this is called X bar to indicate my average. So X and X bar. Anyway, so all I'm doing, guys, is just the subtraction. So 7 minus 18, 11. Again, there will be no negatives here because we're doing absolute values. So 8 minus 18, 10. 10 minus 18, 8. 11 minus 18, 7. 14 minus 18, 4. 29 minus 18, 11. 30 minus 18, 12. 35 minus 30. Or, well, why did I put 30? Wait a minute, it's not 30. It's supposed to be 18. 18, guys. So 17. 17. But anyways, so we have each deviation separately. Imagine, remember when you calculated the mean, which we did over here? We took separate data points, added them all up, divided by the total number of them, got a mean. We found our deviation now, or we found our absolute deviations, right? Two of our three words are wrapped up in this column here. Let me do a different color. Two of our three words in MAD, M, A, and D. Here's A and here's D. We just have to take A and D and find the average of it. So imagine this is a whole new set of data now, and you're just doing like you've done before with mean calculations. Right, so now I have 11 plus 10 plus 8 plus 7 plus 4 plus 11 plus 12 plus 17. 17. And again, there are how many? How many? 1, 2, 3, 4, 5, 6, 7, 8. Oh no, sorry, there are 8. My apologies. I wrote 9. I meant to say 8. When you do 144 divided by 8, you do indeed get 18. My mistake there, guys. That's why it's always good to double check stuff, right? Yes. So, anyways, there you go. I have 8 data points, so divide 8. So add all this up. What do you get? What do you get, guys? You end up getting, if you add all that together, you end up getting AT, 80, 80. Just, for all these right here. You still have this 8. You didn't do anything there, so you're saying 80 divided by 8. Well, right, this, right, it's just 10. It's just 10. Simplifies down to 10. So guys, your average absolute deviation of all of your data points is 10. Your mean absolute deviation is 10. In other words, if you were to be asked about your data set and the story that you were trying to tell, you can say the story that, listen, the average value in my data is 18, and every other point in my data set, on average, deviates from that 18 by a value of 10. Isn't that fascinating, guys? So, in other words, you have center, you have spread. You can put it in a chart and it will result in some shape, something like that, right? Guys, you've just told a statistical story, one of truth. You have just summarized. That's the whole point of statistics, is to summarize, so we don't have to go through pages and pages of data and look through tons and tons of logs. It's when you're presenting data, you're summarizing. You're summarizing. That's the value. So what you're saying is, again, I just want to reiterate, this whole thing is saying that our data set, which is this, the average value, pick any random value, on average, it's going to be 18. And if it's not 18, every other data point, if it's not 18, it deviates from 18 by a value of 10, right? 18 plus 10, 28. 18 minus 10, 8, right? On average, right? So there's going to be some that are outside, beyond 28. There's some going to be below 8, right? Again, guys, that's your center, that's your spread. That is statistics. The only part left is to analyze what this means, get a real visualization, a real shape going. I just kind of threw this together. I assume it looks something like this. Um, and I'll save the charting and all that for another time. But guys, I just told my story here. This is the story of this data set. Now, when you get to higher level math, there's so much more story to tell, so much more. But for intro statistics, you guys are becoming extremely proficient, wonderful statisticians. You soon will be the greatest storytellers of our time. I can assure you, all right? So, with that said, all right, it's kind of when you see mad, when you see it kind of looks maybe a little intimidating. In fact, actually, if for those of you who are interested, here's everything I just said and everything I just discussed. If you think formulas are cool and you're fascinated by formulas, guys, here's the formula. Here is the formula. You're gonna be like, whoa, this is like I give up on math now. I give up on math. Whoa, I don't even know what some of those are. Like what's this huge thing? Don't worry about it, guys, but understand like this is what we just did. Everything else, everything I just explained the last 22 minutes can be summed up with just this formula. Part of the beauty of math, part of the beauty of math. Anyways, you don't need to know this. If you have the idea of what I just went through, step by step, I think that's more valuable for you guys right now. So if you can do this, I'm going to have you guys do some of this on the practice problems. You're going to see this on quizzes and tests. You're going to have the opportunity to flex your mental muscles when it comes to calculating spread. In fact, I hope today you got a real good pump on those mental muscles of yours, guys. I can see them bulging right now. I can see the veins popping right now. You guys are becoming bodybuilders, mental bodybuilding machines. So, I hope you felt the burn today. I hope that this has been of some value to you, and I hope that things are clicking, things are coming together. You're enjoying statistics. As I said before, it's one of the most interesting areas of math, I feel. I hope you feel the same, or maybe you will one day. Who knows? Either way, thanks so much, guys. I will see you on the next video. Take care.